Today we're working on section 5.5, solving exponential and logarithmic equations. We're going to start off with the exponential equations. So I have the first one written here for us. We've got 10 to the x power equals 0.01. Well, this is very similar to simplifying our logarithms. Remember, we can switch our equations back and forth between logarithmic form and exponential form, so some of the techniques are going to be similar. So on this side we've got 10 to the x. Well, if we can get this side to be 10 to some power as well, we're going to be able to know what the x is. Okay, well then ask yourself, 10 to what power is 0.01? Well, you might not know right off the bat, so you'd get your calculator out and put in 10 caret, and I don't know, let's start with -3, enter, and we see it's 0.001. Well, that's a little bit too many zeros, so let's try 10 caret -2. And that does give us 0.01. So even if you don't know it off the top of your head, you can get your calculator out and kind of guess and check until you find what works. Okay, but we just said that 0.01 is the same as 10 to the -2. And that's the whole point. You want to get the same bases, 10 and 10, and then you set your exponents equal to each other. So x equals -2 here. Part B, I've got 3 to the 2x minus 1 equals 27. Okay, well again, take a look at your bases. See if you can get the bases to be the same. Okay, well I've got a base of 3 over here. 3 to what power is 27? Well, 3 to the 3rd power. So I'm going to replace it. And we got our bases the same. So now we can set our exponents equal to each other. 2x minus 1 equals 3. This one's not quite finished. We do need to finish solving the equation that's left over, but it's linear, so we'll just get x by itself, add the 1, and divide by 2. Okay, and notice I'm not checking my answers when I'm done, but with any equation you can always go back, plug the number back in, and see if it works. Okay, as long as you did all the steps correctly, there's no need to check in this case, but with logarithmic I'll show you what we need to do. Okay, part C, I've got 2 to the x power equals 1/2 to the 13th power. Okay, well this one, it almost looks like we have the same bases. It's just on the bottom. We want to move it up to the top. Remember, when you move something up to the top or when you move it down to the bottom, it just changes the sign of the exponent. Before we can do that, we need to take the 1/2 power to the 13th power so that we've got them to the 13th power individually. But 1 to the 13th power is still going to be 1. And so on bottom we have 2 to the 13th power as well. All right, now we'll move it up to the top. And that'll just change it to a -13. And now we have the same bases, so we can set the exponents equal to each other. Okay, part D. I've got 6 to the x minus 7 equals 7. Oh, now this one, we look at our bases and I'm thinking about, well, is there anything 6 to some power that'll give me 7? Definitely can't think of anything. Maybe 3 to a power, but no, that's not going to work for either one of them. Okay, so when it gets difficult and you can't figure out how to get the bases the same, there is another trick. you can take the log of both sides. And more specifically, I would take the log base 10 or the natural log because you have both of those keys in your calculator. Okay, but I'm just going to do log base 10 for this example. So let me take the log of both sides. And then what can you do with an exponent? You can bring it down in front. Okay, and it looks more complicated than it is. Remember that log 6, you can just put that in your calculator and get a decimal. Log 7, you can put that in your calculator and get a decimal. So these are just numbers. I'm not going to put them into the calculator until the end to make sure I get the most exact answer possible, but just remember that they're numbers. Treat them as numbers. So we're trying to get x by itself. Well, first of all, I need to cancel the log 6 out, so I'll divide by log 6. And finally, to get x by itself, I can add 7 to both sides. Okay, and then we'll just put it into our calculator and find our answer. Okay, so you're just going to put it in the way you see it. We're going to press in log. I like to use parentheses to make sure I know that it's taking the log of only what I want it to be taking the log of. So I'm going to put parentheses, 7, parentheses. Sometimes some of your calculators will already start to give you the parentheses. Just make sure you close the parentheses then before you divide by log. And then I'm going to put parentheses, 6, parentheses, and then plus 7. Enter. And I got 8.09 if I round. Okay, let's try another one like that. Part E. I've got 3e to the 5x equals 11. Okay, well, the first thing I need to do is get that e to the 5x by itself. So I'm going to divide by 3. And then I've got e to the 5x equals 11 thirds. Okay, and again, it's going to be hard to think about it in your head to get these bases to be the same. But we can use our trick that we just learned. And you feel free to use log of both sides, but since we have this e, I know the natural log has base e, so it's going to be a lot less work to use ln on both sides. Because then I've got the same base here and number here. This just simplifies to 5x. And then finally, to get x by itself, I'll divide by 5. And again, plug it into your calculator and see what you get. So I've got ln parentheses 11 divided by 3, then close the parentheses. See how the parentheses are really going to help you out, because now we want to take the natural log of that fraction. It's not just a single number. Okay, and then divide by 5, and I got 0.26 approximately. Okay, so now I've shown you two different ways to solve exponential equations. You can either try to get the same bases on both sides and go from there, or if you can't get them to be the same base on both sides, you can take the log or the natural log of both sides and go from there. Okay, now let's take a look at our logarithmic equations. Example 2. Solve the following logarithmic equations. Part A, they give me log of x equals 2.3. Okay, well, the easiest way to approach these when, excuse me, when you've got the log of your variable is to change it into exponential form. That's the whole reason why we learned how to go back and forth. So right up here, let me write down what our formulas were. So log base A of x equals k. We can transform that into x equals a to the k. And I'm going to go ahead and write out what each piece was. Okay, so we don't have the base written. That means it's base 10. Okay, and then our x, well, it's x in this case anyways. And our k is 2.3. Okay, then we'll just go ahead and plug them in to the formula over here. So we've got the x first, which is just x, equals my a, which is 10, and to the k power, so 2.3. And notice, once we've changed it to exponential form, well, it's very simple. Now we just need to put 10 to the 2.3 in our calculator and get the answer. Okay, so I already did that, but do that in your calculator. You get 199.5262. Or if you only want to round to 2 decimals, that's fine. Okay, make sure you read the directions and see what the directions ask for. Let's try another one, part B. I've got log base 2 of x equals 1.2. Okay, again, I'm going to change it into exponential form. So I'm going to label all my pieces. My a in this case is 2. My x is x. And my k is 1.2. Okay, so then I'll plug them back into exponential form. So I get x equals 2 to the 1.2. And put that in your calculator. You get 2.2974. Okay, and with logarithmic equations, you should just check to make sure when you plug it in that you're taking the log of a positive number. Because remember, whenever you take the log of 0 or the log of a negative number, it's undefined. So make sure that's one thing that you have to check when you're done, that you're taking the log of a positive number. We are in this case, so we can keep it. Our first one was fine as well. Okay, we'll just do a couple more. Part C, I've got ln 2x minus ln 4 equals 3. Okay, well in this one, we need to do what we learned in the last section. We need to condense. We need to put our logs together. Okay, so we've got a subtraction in between. That means when we put these logs together, we're going to divide. So we've got ln 2x divided by 4 equals 3. And we can simplify that. The 2's, we can cancel a 2 from the top and bottom. We've got ln x over 2 equals 3. And now we'll do the same thing that we did in the last example. We'll change it to exponential form. So this time the a is e, because the base of ln is e. My x this time is x over 2, and my k is 3. And we'll plug them into exponential form. So we get x over 2 equals e to the third power. And finally, to get x by itself, we need to multiply by 2. Okay, and again, put that in your calculator, get the decimal form, and let's see what I got. 40.17. Okay, and again, that's good because when we plug it back in, we're taking the log of a positive number, so we're good to go. We can keep that answer. Okay, let's do one more. Let's see if I can squeeze it in right here. Part D. I've got ln 2x minus ln, oh, that's the one we just did. Part D, I've got log x plus log of 4x